All right, peeps, let's do an example for accumulation. This is AP Calculus AB problem 2000 from 2002. It's question 2. Question 2 tells me we're talking a calculator question. All right, let's see what we're given here. So it says the rate, okay, right away. We got a big word right there, rate. We're talking about a rate. We're talking about a derivative in my brain. That derivative is either given or I'm going to have to find it. It says the rate at which people enter an amusement park on a given day is modeled by the function e, defined by e of t is equal to this guy right here. This, I'm going to put right in parentheses, this is a rate. The rate at which people leave the same amusement park on a same day is modeled by the function L, defined by this. Okay, this is a rate. This is the rate they're entering. This is the rate they're leaving. Okay, so as we go through, we need to make sure we're interpreting these as rates when we're going to interact with this information. All right, so both E of t and L of t are measured in people per hour, and time t is measured in hours after midnight. These functions are valid for 9 to 23, the hours during which the park is open. So it looks like the park opens at 9 a.m., and this would be maybe like 11 p.m. would be t equals 23. At time t equals 9, there are no people in the park. All right, so how many people have entered the park by 5 p.m.? T equals, this should say t equals 17. Round your answer to the nearest whole number. How many people have entered the park? Well, the information we're given is the rate at which people enter the park. And when I integrate a rate, that is going to tell me how many total people have entered the park. So for this one, again, think about what calculus we're going to do here. I'm going to integrate from by 5 p.m. So I would integrate from 9 until 17. And I'm going to integrate e of t dt. And remember, this is a calculator problem. And notice how I did not write this whole function in there. I don't need to. It's defined as e of t. I'm doing this all in my calculator. So just let me get my calculator set up here. And let's substitute e of t into our calculator. I would highly recommend doing this right with me. I'm not going to do it for y sub 3 though. I would have 15,600 divided by, make sure we're using parentheses. I gotta get out of that exponent somehow. I'm just clearing it out. Divided by x squared minus 24x plus 160. Blam. All right, you know what? I'm also just going to put L of t in here right now since I'm in here. I bet I'm going to use that at some point. And let's see, that's x squared minus 38x plus 370. Boom. Okay, so we said we're going to integrate y sub 1. I'm going to maybe label that in my diagram or in my problem to remember which ones I have them as. All right, so let's go to our calculating screen. We're pushing math. We got 9. We're going from 9 to 17 of y sub 1. And boom, does all the work for me. And it says 6,004. This said round to the nearest whole number. So I would just say is approximately 6,004 people. Dunzo with that one. All right, let's go to letter B. So letter B, again, read carefully. The price of admission in the park is $15 until 5 p.m. After 5 p.m., the price of admission to the park is $11. How many dollars are collected from admissions to the park on the given day? Round your answer to the nearest whole number. Okay, so I get $15 per customer from until t equals 17. So the number of people that enter the park is going to be the integral from 9 to 17 of e of t, but I'm going to multiply that times 15. That's going to give me the total amount of money. Plus, I'm going to get $11 after that. So I'm going to do 11 times the integral. This is going to go from 17 to 23 because the park will close after that. And this is going to be the amount of money. This is the total number of people that enter from 9 to 17 because I'm integrating this rate. This is the number of people that enter over this time period because I'm integrating a rate. And then I would multiply those accordingly by how much each thing cost. And then I also want to always be thinking about what am I doing in this problem that I need to show. And this is what I would need to show. What calculus am I doing? I'm integrating these. I'm multiplying them by these things accordingly to the price. All right, the rest of this is calculator work. And don't do the work by hand when you can use your calculator. So we'd have 15 times the integral, which will be math 9. I'd go 9 to 17 of and the y sub 1 and an x plus 11 times the integral, and I'm going from 17 to 23, and again that's y sub 1 and x, and boom, and what do we end up with? We get approximately and it says round to the nearest whole number, 104,048, and that's going to be dollars. All right, let's check out letter C then. So letter C says let h of t, this should say equals again, I print it weird. Let h of t equal the integral from 9 to t of e of x minus L of x dx for 9 to 23. The value of h of 17 to the nearest whole number is 3,725. Find the value of h prime of 17 and explain the meaning of h of 17 and h prime of 17 in the context of the park. Okay, so let's take a look at h of t and think about what they give us here. So h of t is an integral from 9 to some time of e of t minus L of t. So this is the rate people are entering minus the rate people are leaving. So I think together this is like how many total people, it's like a rate of change of the total people in the park when I look at that, or it's the rate of change of that, yeah. All right, so let's do this. So when I integrate this right here, h of 17 is going to represent, I think this would be, if I separated these out, this would be the total number of people that entered the park when I integrate the entrance, minus, this is going to be the total number of people that leave the park. So the combination of these, integrating both of them, is going to be the total number of people that are in the park. So h of 17 equals 3,725 is the total number of people in the park at t is equal to 17 hours. Or in other words, I think that's 5 p.m. Notice how I'm explaining everything. I'm explaining what this is. This is the number of people. 17 is the time, or how many, after how many hours. Okay, the next one says we got to find the value of h prime of 17. Well, if I do h prime of 17, that's going to be the derivative of this. When I take the derivative of this side, I'm going to use my second fundamental theorem that says the derivative is going to cancel the integral. We know this t is going into this. So this would be e, I'm going to write this as a t at first. H prime of t is equal to e of t minus L of t. And h prime of 17 would be e of 17 minus L of 17. So let's think about what h prime of 17 is based on what these are. Well, e of 17 is the rate at which people are entering the park at 5. This is the rate at which people are leaving the park at 5. So let's calculate that. So this is approximately, in my calculator we'll do function notation. So let's use our calculator for this one. So I'm going to do variable. I know I did my e function as y sub 1 of 17 minus y sub 2 at 17, and boom, we get negative 380.28. And does it say anything? Find the value, explain the meaning, context, prime. Okay, so this is h prime of 17. All right, we need to explain what that means. So h prime of 17 is approximately negative 380, and actually I should go one more decimal. I'm going to put a 1 there because we should go another decimal. Is approximately negative 380.281 is, so this is the rate of people entering minus the rate of people leaving. So this is like the overall rate of change of people in the park. So h prime of 17 is the rate at which the total number of people in the park is changing at t equals 17 hours, which is 5 p.m. So this is how much the total, so at 5 o'clock, the park is decreasing by 380 people per hour. So I should say, is the rate at which number of people in the park is changing, I should say per hour to have a label here. All right, let's go to D. And what's left, they could possibly ask us about this. So at what time, T, for between 9 and 23, does the model predict the number of people in the park is a maximum? All right, a maximum. So we know the derivative is going to change, and I'm going to use f prime. F prime is going to change from positive to negative. So we're going to need the model that we're going to use is going to be the number of people in the park. Well, the number of people in the park was this h of t. So I'm going to start by saying, first of all, the number of people in the park is equal to the integral from 0 to t of e of t minus L of t. And I'm going to do the maximum I would find when the derivative changes from positive to negative. So if I do the derivative, we've already figured out h prime is equal to e of t minus L of t. And what we want this to be, to figure out when this is going to go from positive to negative, I'm going to do a 0. All right, so I could do this in my calculator and figure out when it's 0. But it's going to be 0 specifically when e of t is equal to L of t. And that's going to be easier for me to figure out in my calculator. And I'm going to need to graph this. Actually, no, I lied. I think this is going to be easier to figure out in my calculator. Because otherwise, that would be the intersection of these. My calculator is much easier to figure out a 0 in terms of the window. So in our calculator, let's graph this. So this is going to be y sub 1 minus y sub 2. Boom. I'm going to turn these other graphs off. All right, so then I'm going to graph. Let's think about a window here. And I already done this problem. So I'm going from 9 to 23 because that's the range of values they gave me. And what do I want this function to be? Is 0. So I'm just looking at y's. I don't care how wide this gets. I just want to know when is it equal to 0. So I'm going from y min negative 1 to y max of 2. Let's graph this. Let's see what happens. All right, so it goes through 0 one time. So remember, this is 9, 10, 11, 12, 13, 14, 15. So it's between 15 and 16. So let's find our intersector. Let's find our 0. And for left bound, I'm going to type in 15 to tell it that's the left bound. For right bound, I'm going to type in 16. So it's in between 15 and 16. It says guess. It's more towards 16. So let's see where it has me. Maybe I'll go back a little bit. And then I'm just going to push enter. And you wouldn't even have to guess. And it gives us at t equals 15.795 hours. All right, let's check out and make sure we answered that question. At what time does the model predict the number of people in the park is at a max? I'm gonna explain. The number of people at t is approximately 15,000. Actually, you know what? It doesn't say to explain. It just asks for when is it at a max. So otherwise, I was going to say it's at a max because h prime of t goes from positive to negative based on this graph. But it doesn't say to explain, so I'm not going to explain. I'm just going to give the number of hours. All right, let's check out how we did. Oops, that's not the answer key. Here's the answer key. So for the first one, this is exactly what we did. We were not predicting what we're going to get points for. Let's do that right now. What would we get points for in letter A? We should have been doing that throughout. Well, I'm going to get points for calculus. I'm going to get a point for this integral for sure. I'll probably get a point for this answer if I had to guess. What am I going to get a point for here? I'm going to get a point for these integrals. Probably going to get a point for multiplying. Just for this whole thing, I'm probably going to get 1 point because that's explaining what I did. Probably going to get a point for the answer. Letter C. What were our goals in this one? We had to explain the meaning of this. I would probably get a point since they said that. I'm probably going to get a point for realizing that h prime is equal to e of t minus L of t. Why would I get a point for that? Because that's calculus. We use the second fundamental theorem to say the derivative cancels the integral. So that's going to be calculus. I'd probably get a point for that, so I'd want to show it. Probably get a point for this. Probably going to get a point for this explanation as well. All right, in the bottom one, what am I going to get a point for? I'm definitely going to get a point for an answer. I'm probably going to get a point for this part right here saying, hey, we need to find when the derivative is 0 in order to determine a max or a min. Again, I might not be perfect, but we always want to be thinking about what we are writing. All right, let's check out how we did. All right, to number 1, the pencil just ran out of lead, so I'm using pen now. We got a point for the limits. Okay, so from 9 to 17, we get a point in that one. We got a point for this integrand, and we got a point for the answer. And they wanted it rounded to this. They probably would have given you points for that. Because usually what they do is they look to what they want and they ignore the rest. All right, setup, you got 1 point. So for letter B, I don't know what this is. Just got a point for the setup. All right, so I guess you just got a point for this. And I think that's the answer we got right here. So you just got 1 point for letter B, and this is the point that I bet you got a point for, is this right here, this setup. And that's exactly what we did for a setup. Okay, letter C, h prime of t, what we said, let's see, it says value of h prime, so we got a point for this. There were 3,025 people in the park at t equals 17. The number of people in the park was decreasing at a rate of approximately 380 people per hour at t equals 17. We got points for h prime, this. We got a point for the meaning of each one, we said. And then we lost a point for no reference to t equals 17. So if I didn't say that I was at t equals 17 hours, I wouldn't have got points. And the reason is because this rate is very specific. It's exactly at t equals 17 hours when this rate is going to occur. So that's why they want you to make sure you reference t equals 17. And then on this one, you got a point for e of t and L of t minus L of t is 0. I thought we would get a point for that because that's the calculus we need. In order for there to be a max, we want to look for where the derivative h prime of t is 0. And then we got a point for the answer. So I think we got all 9 points. We will not get every point every time, but we'll do well on all of these. And when we don't get every point, we may get 8 out of 9 on some as we go through these. We'll make sure that we identify, hey, we didn't get a point because of this, because those are really good learning moments for us. All right, so you're going to go on to your FRQ for this and do your best on those. Make sure you're checking your answer key, and good luck on that problem.